You've already seen some examples of functions. In this video, we're going to go into more detail about how functions work. One of the basic ideas about functions is that they can accept inputs and produce outputs. This varies a lot with the individual functions. Many functions have both inputs and outputs, but some functions only accept inputs, but do not produce outputs. In addition, some functions will produce outputs, but do not require any inputs, and some have neither inputs nor outputs. Throughout this semester, you'll see examples of all of these. Next, some fundamental vocabulary. The inputs to a function are called parameters, or arguments. There is a technical distinction between these two terms, and the textbook covers it in some detail, but I will not be emphasizing it this semester. For our purposes, I will treat both these terms as synonyms. When you call a function, you always put parentheses around the parameters. Even if the function does not accept any parameters, you still put an empty pair of parentheses after the function name. That's an easy visual difference between functions and variables. Function names are always followed by parentheses, while variable names are not. Some functions produce outputs. We call these outputs return values. Functions don't do anything until they are called. To call a function, you state its name, followed by 0 or more parameters inside the parentheses. Here's an example of calling the absolute value function. We type the function's name, abs, with the input parameter -8 inside parentheses, and we're storing the return value into a variable x. Let's illustrate the concept of functions with an example. When I was a boy, my parents had a tomato juice machine. We'd put boiled tomatoes into a funnel on the top, turn a crank, and fresh tomato juice would come out the bottom. The tomato juicer machine is like a function. The inputs, or parameters, are the boiled tomatoes. The output, or return value, is the fresh tomato juice. But even though the tomato juicer is a brilliant machine, it won't actually do anything until you turn the crank on the side. In like manner, a function, no matter how well written it is, will not run until you call it. Let's take this metaphor one step further by revisiting the image loading example we did in JES. So in this example, I've gone ahead and I've selected a file name. You can see it's the Big Ben file that we did last time. Now let's try loading this file into memory in the form of a picture. Remember, the makePicture function will do that for us. So I call makePicture file name. If you call a function and don't do anything with return value, then all JES can do is display the return value in the command area. You don't actually get to use it for anything in your program. This is like running a tomato juicer and just letting the juice spill all over the floor. You can do it, but it's not very useful. Let's look at another way of doing this. What if instead of just calling the function and letting the output print to the console, what if we pass it right away to the explore function? Explore makePicture file name. So here I'm calling the makePicture function and then immediately taking its output and feeding it into the explore function as its input. Let's see what this does. It displays the picture just like we want. Calling a function and then immediately taking its return value and plugging it into the input of another function is like putting your mouth right underneath the tomato juicer. The output is not wasted, but there's no way to save it for later either. In programming, this is sometimes acceptable if you know that a certain output will only be used once. Perhaps the best way of solving this is to call the makePicture function, but then store its output into a variable. I'll call the variable Ben. So here I've called the makePicture function, but instead of feeding it right into the explore function, or instead of just wasting the output on the command prompt, I am storing the output into a variable. When I do this, now the computer is storing this image in memory, and it's given it the name of Ben. So now if I want to explore Ben again, I can do that easily. There it is. And if I want to view it again, I can call this as many times as I want to. The Ben picture is already in memory. There's no need for the computer to reload it from the disk. In the tomato juice world, the most common and practical thing to do is to store the tomato juice in a bottle. That way you can store it for later use. This is like storing a function's return value into a variable and giving it a name. When you store data into a variable by giving it a name, this allows the computer to remember it so that it can be recalled for later use. For functions that return values, you should always store the return value into a variable unless you know for sure that you won't need it later on.